Limit problems. Probably a good idea to do direct substitution as a first step. So on 14, if I try to direct sub infinity, think of that as like 10 million. If you plug 10 million in here, I'm going to start with the bottom. 2 times 10 million is going to give you a big number. 2 times infinity is going to give you infinity. So if I get anything else on top, then my answer will be 0, because a finite number on top divided by infinity would give you 0 as a result. And in fact, if you think about what the sine graph looks like, the sine graph is a wave that never gets less than -1 and never gets greater than +1. So even at its peak, regardless of what x value, what angle you're plugging in, even a gigantic angle is at the very most, when you take the sine of it, going to give you a result of 1. That's at its max. And 1 divided by infinity is simply 0. Number 15, we talked about that as being really a theorem. Well, I'm getting ahead of myself. Let's direct sub this. Sine of 0 is 0, and 2 times 0 is 0. So what I'm going to do here is I'm going to, because sine of theta over theta, as theta approaches 0, we should hopefully know by now that that's just a value of 1. I'm going to pull out the 1/2 constant that's left over after I factor out that sine theta over theta. I'm going to pull the 1/2 out and then just take limit as theta approaches 0 of sine theta over theta. I'm going to show that this much equals 1. Obviously this is a half. When you multiply them together you get 1/2. And finally, if I do direct sub on this last piece, sine of theta over 2 theta. Well, sine of, I said theta instead of pi. Sine of pi over 2 pi. Sine of pi is 0. That's the west coast of the unit circle. And 2 pi is 2 pi. 0 divided by 2 pi is just 0.